So in this problem, we're told that a triangular block of Swiss cheese of height 12 and width 8 is lying upon a wooden ramp of angle theta with which it has coefficient of static friction mu sub s. We're told that the block of cheese has a uniform mass density, or we're led to assume that. And we're asked whether the block of cheese will slip down the ramp first, or will it start tipping over. So first, I'm going to assume that the block slips first, and I'm going to calculate at what angle this is going to occur. Now, if this angle is less than the angle that the block will tip at, then that will happen first. If the angle is greater than the angle that the block will tip at, then the block will tip first. So first, we're going to remember that the force of friction is less than or equal to, mu sub s times the normal force, since we're talking about static friction here. And this is just equal to mu sub s times mg cosine theta, since the normal force, which is acting here, has this component mg cosine theta, which will generate the normal force. So now all we need in order for the block to slip is for the parallel component in this x hat direction of the force of gravity to be greater than the maximum force of static friction. So for that to happen, we need mg sine theta greater than mu sub s mg cosine theta. Now here we can cancel the mg's. This is a fairly simple inequality. We get sine theta is greater than mu sub s cosine theta. Tan theta is greater than mu sub s. And theta is greater than arctan mu sub s. Now mu sub s is 0.90, and so the arctangent of that is about 42 degrees. So if theta is approximately greater than 42 degrees, the block is going to begin slipping down the ramp. Now, in order to prove that this is what actually happens, I'm going to show that the block will not tip until the angle of the ramp reaches past 45 degrees. Now, my argument for this is going to hinge around the idea that the center of mass of this triangle is going to lie 4 centimeters above the center of the bottom edge. Now you can do this calculation on your own. Remember that the center of mass calculation is just the integral of the coordinate times dm divided by the total mass. But I'm going to trust that you can do that on your own. So given that this is the case, we have a distance 4 from the center point, which will be a distance 4 from the lower left-hand corner of the triangle. And so this makes a 45-degree isosceles triangle. So now what this tells us is that when we draw our little isolation diagram for the triangle, if the triangle is just about to tip, right before it tips, the only point that will be making any, that will have any real normal force from the ramp is going to be this lower left-hand corner, because that's the point that it's going to tip around. So that's where the normal force will act. The force of friction will also act there. But the force of gravity will still act from the center of mass. So now if this is held at an angle theta, we know that this angle is 45 degrees, since that's just a smaller version of this this isosceles triangle right here. So all we need in order to have the block tip to the left is to have this force of gravity act to the left of this corner reference point right here. Since it's tipping about the reference point, about that corner, the normal force and the force of friction will have 0 torque. So if the force of gravity is to the right of that point, then torque will tend to spin the block to the right, which wouldn't make any sense because the ramp is in the way. If the force of gravity points to the left of that reference point, then the block will begin to tip, falling down the ramp. So we're just going to calculate that the block is just about to tip, which means that the force of gravity will run exactly through the reference point. There will be a complete zero torque. And so, I'm not sure if you can see this, this 45-degree angle also has the angle theta down here, just based on geometry, the angle theta with the horizontal. And so this tells us that if the force of gravity points directly through the reference point, then it will have to point directly downwards in order to be vertical, which tells us that theta will have to be exactly 45 degrees. So the block will tip at any angle theta greater than 45 degrees, because at that point the force of gravity will be acting to the left of the reference point. However, the block will have already begun to tip when theta exceeded 42 degrees, or will already have begun to slip. So this tells us that the block will slip before it begins tipping.